In this lecture we are going to discuss about half adder and half subtractor. Before starting the topic, I want to give you some basics about MSB and LSB. So let's see what is LSB and what is MSB. So MSB stands for most significant bit and LSB stands for least significant bit. Suppose initially we have the values 000 for A, B and C. So if we increase the value of C by 1, then the decimal value increases by only 1, because we know that 001 means 1 in the decimal. Instead, if we increase B by 1, then we will get the decimal value as 2, because we know 010 means 2 in the decimal. And if we increase the bit A by 1, then we will get the decimal value as 4, because we know that 100 means 4. So we can see that adding 1 to A has the most significance and adding 1 to C has the least significance. That's why we say that A is the most significant bit and C is the least significant bit. So we will use this concept to understand adder and subtractor more clearly. Half adder is actually the adder of two bits. In this case we have the bits X and Y, which are the inputs, and we have the outputs of the half adder as C and S, where C stands for carry and S stands for sum. So let's see how we can get the outputs C and S, and we can simply find them by adding X and Y for each pattern. Okay, let's do this for the first pattern. For the first pattern we have X as 0 and Y as 0. We will find the addition of X and Y. So for this we will get the result of addition as 0, and I will write in 2 digits, where this bit represents sum and this bit represents carry. So for the second pattern we will add again, we will add X and Y again, and we will get the result as 0 1, where 0 is the carry and 1 is the sum. For the third pattern we will get the output as 0 1, where this 0 is carry and this 1 is sum. For the last pattern the result of the addition will be 1 0, because we know for binary numbers if we get the result as 2 in the decimal form, this is 1 0 in binary form. That's why we will get 1 0 for the fourth pattern, and in this case 0 is the sum and 1 is the carry. So we see that for sum we are getting the outputs 0 and 1 1 and 0. For carry we are getting the outputs 0 0 0 and 1. Okay, in this way we can easily find the outputs C and S. So in half adder we have simply added X with Y, and we have written the results in 2 digits. So we have got the results like these: 0 0 0 1 0 1 and 1 0, and we are saying that our MSB is the carry and our LSB is the sum. So this is actually MSB and this is LSB. Okay, now we can write the boolean expressions for sum and carry. We can write in sub form or in pos form. I have written here in sub form, and you can see these are in canonical forms because there are all the inputs in each term. For this one we will write x prime y, because in this case x is 0, and for this case we will write x y prime. So we will put an addition sign here, and we know this is the expression of XOR gate, so we can write x XOR y as we have written here for the sub form. That's why I have considered the outputs where they are ones, and for carry there is only single one, and for this one the input pattern is 1 1, so we will write xy for the carry. And finally you can easily draw the logic diagram like this, where sum means x XOR y, so this is x XOR y, and this is xy. So this is the basic of half adder. Now let's see half subtractor. Okay, for half subtractor also we need 2 bits. So here we have two inputs x and y, and in half subtractor we will find x minus y for each pattern, and we'll write the outputs in borrow and difference. So here b means borrow and d means difference. So before understanding half subtractor, let's review the concept of subtraction in decimal form. So suppose in decimal you want to subtract 16 from 23. So what we simply do is we subtract digits position by position. First we subtract for this position and then for this position. And for the first position we know that we can't subtract 6 from 3. That's why we borrow 1 from the next position to the previous position. And as the base of decimal numbers is 10, that's why we will add 10 to the previous position and then subtract 6 from 13, so we will get 7. And as we have borrowed 1 from the next position, so we will find 1 from here at first and then minus the borrowed 1, so we will get 0.7. Similarly we can do the binary subtraction. Let's find the results for x minus y for each pattern. For the first pattern we will find the result 0, because 0 minus 0 equals to 0, and this 0 is the result of difference. And for this subtraction, as we didn't need to borrow anything, that's why borrow will be 0. Okay, for the second pattern we can find that now x is 0 and y is 1, and we can't subtract 1 from 0, that's why we need to borrow 1 from the next position. And as for binary numbers the base is 2, that's why when we borrow we need to borrow 2, that's why instead of 0 we will now borrow 1 from the next position to the previous position, and in the previous position we will add 2 instead of 10, because previously in the decimal numbers the base was 10, but now as we are dealing with binary numbers the base is 2, that's why we have to do the subtraction from 2. So we will find the result as 1, because 2 minus 1 equals to 1, and this is the result for difference. And as we borrowed 1 from the next position, so the result of borrow will be 1 here. Similarly we can find for the third and fourth positions. For the third position we can do the subtraction like this. This is the result for difference, which is 1, and we didn't need to borrow anything, so for borrow it will be 0. For the fourth position 1 minus 1 results in 0, so we will get 0 in difference, and as we didn't need to borrow anything we will get 0 in the borrow. So this is the truth table of half subtractor. Now we can easily write the boolean expressions. I have written here in canonical sub form. We need to write the canonical sub form, that's why we will find the ones in the output. For difference we have the outputs in this position and in this position. So for this position we will write x prime y, and for this position we will write xy prime, and we know this is the expression for x XOR y, so I have written it. For borrow I have only single one in the output, so for this one I can write x prime y, so this is x prime y, and you can simply draw the logic diagram. For difference we need XOR gate, and for borrow we need x prime, so we have used an inverter and then have given it to the AND gate with another input as y, and we have got borrow. So that's all for this lecture. In the next lecture we will learn about full adder and full subtractor. Thank you.